Today we're going to be doing the A-5 notes on solving equations. We're going to be solving linear equations, radical expressions, and rational expressions that are set equal to values, and other quadratic equations. So here we go. The first thing what you need to know about is what is the difference between an equation and an expression. If you look at the words, equation kind of sounds like equal. So equations are going to be any mathematical statement that has an equal sign in it. So what I have is that x plus 5 is equal to 3. You can actually solve for x for this equation. The next one, expressions, they're not going to have equal signs, and really you can only simplify them to their simplest expression or simplest form. And an example of that would just be x plus 5. Some other types of things that you should know about when dealing with equations is that sometimes you'll have an identity equation, which means that the two sides on the left and right of the equal sign are going to be equal to each other. For example, x squared minus 9 is equal to x plus 3, x minus 3. This is going to be true for any value of x. So you could put in 2 on this side, and it should equal what you would get if you were to put 2 on the other side. Another thing about equations is that you can also have conditional equations, and these are going to be the ones that we use the most. It's when you have an equation set equal to a certain amount, and it's only going to be true for a small amount of numbers. For example, here x squared minus 9 is equal to 0. This is only going to be true when your x value is positive and negative 3. All right, so to get us started, and you've been solving linear equations for a long time now, so I was going to kind of just breeze through this. And a linear equation, if you keep in mind, I know that this is ax plus b. You're more used to seeing it into mx plus b format, where m is your slope and b is that y-intercept. And that will help with graphing purposes, but we're not really going to be graphing too much in this chapter. So here we go. We're just going to solve. So let's see. All you're going to do if you have an equation in y is equal to mx plus b format, go ahead and you just isolate the x. So 3x equals 6 and divide by 3. I'm sure that you've been doing this for a long time now. It does get a little bit more complicated when you have fractions, and this is good practice because you can kind of see down here we have some crazy old fractions going on. If you remember from the last section, you're going to multiply by the LCD, or the least common denominator. For this case, if you look at your denominators, you're going to get 12. 3 times 4 is 12. What happens when you multiply by the least common denominator with an equation is that the denominators go away. Whereas last chapter, you combine them over a common denominator, and we can kind of cover that again in class if you want. So what I'm going to do, I'm going to distribute a 12 into all of these, and if you think about it, 3 goes into 12 4 times. 4 times x is going to give us 4x. So 3 goes into 12 4 times x is 4x. And then you can do the same thing. 4 goes into 12 3 times. 3 times 3x is 9x. And then 12 times 2 is 24. Once you have this, you can just add your x terms and solve for x by dividing. Keep in mind that there will be times when your solution that you get doesn't actually work. I will say some things that you should look for is if you ever have a square root in your given equation, you might have an extraneous solution. Whenever you're given absolute values in your equation, you may have an extraneous solution. And if x is in the denominator, I'm just going to write denom. That may be an extraneous solution or something that produces an extraneous solution. Really, for these, just make sure that you check your answers. And what I mean by that is once you get x is equal to 24 over 13, plug it back in the equation and see if it works. Well, of course, because I talked about it, this next one will have an extraneous solution. But let's get used to solving these. What you should think about is this was an awful lot like example B where we had those fractions, and we're going to treat it the same way. But you might notice that your LCD is going to probably be a little bit more complicated. If you remember back to last section, we would take all the denominators and FOIL them or factor them out to get all the factors that are present in the denominator. And then the LCD just took one factor from each of the fractions, and you never repeated. So once you got x minus 2 from this one, you wouldn't need to use it from this one, and this one would be x plus 2. We're going to do the same idea. If it helps you to write out each of the fractions separately and simplify from there, please be my guest to do that. For time's sake, I am going to kind of go through the same process like I did over here. So pause and rewind anytime you need to. So what I would say, if I'm multiplying all of this by my LCD, if I were to take this fraction times the LCD, the x minus 2 would cancel with this x minus 2. So then I would just have 1 times x plus 2 up top. Here, this x plus 2 is going to cancel with this x plus 2. So on the top, we're going to have 3 times x minus 2. The awesome thing about this one is even though it is the most complicated denominator, everything in this denominator is going to cancel with everything in this LCD, and you're going to be left with minus 6x. Once you're here, you can distribute and combine like terms, so you're going to have x plus 2 is equal to 3x minus 6 minus 6x, leaving you with negative 3x over here. I'm going to add 3 over here and subtract 2 over to here. So this is going to become 4x is equal to negative 8, which means that x is going to equal negative 2. So here our answer is negative 2, but if you use this and you were to put it back up into this equation, what's going to happen is when you put negative 2 into your original equation, especially particularly for these two parts, you're going to have negative 2 plus 2, which for this particular fraction is going to give you 3 over 0, which is undefined. You can't have that happen. So if that's ever the case, if you take an answer and it provides some sort of undefined solution for any part of your original equation, it is extraneous. It actually does not exist. Okay. So moving on, we are going to be solving quadratic equations. There's tons of ways to solve quadratic equations. You could use factoring, which is what we're going to do the most. I know that this is completing the square. We're going to focus on this later, just because anytime you use completing the square, you can also use factoring. So if you ever run into a problem where it asks you to complete the square, just go ahead and use one of the other 3 ways to do it. Square root principle, so that's going to be if you are able to take the root of both sides, and then using the quadratic formula, which Ask Me Tomorrow, there's a wonderful song that goes along with it. It's quite famous. So factoring, what you need to know, if you have 2 multipliers that are going to multiply out to get 0, either the first part 0 or the second part 0, that's really where factoring comes from. What you also need to do is that you have to set your original equation equal to 0. So set equation equal to 0. So for this particular one, I'm going to subtract 3 over, leaving me with 2x squared plus 9x plus 4 equals 0. Here you have factoring. I know that 2 is kind of complicated when it's in front of the x squared, but if you think about it, the only values that multiply out to get to 2 are 2 and 1. So I bet one of these is going to be 2x and the other one's going to be x. And then what you can do is play around with the factors of 4, and when you FOIL them out, see whatever ones add up to get to 9. I know that 4 is divisible by itself in 1, and I also know that 2 times 4 is 8, which kind of gets you close to 9. So I'm going to make this plus 4 and plus 1, and you can kind of check 2 times 4 is 8, and then plus another 1 gets you 9. So here's our factored out statement. What you can do is take each part then and set that equal to 0. I'm used to hopping through that step. So then you're going to have x plus 4 equals 0. So then x is going to equal -1/2, and here x is going to equal -4. Again, take those and see if they work in your original equation. If they do, they are solutions. Right. Moving on to the next page. I wrote a little bit in here previous to the notes. For the square root principle, if you're able to isolate the squared term or the roots, then that's going to be helpful for this. So if you look at this example, here's the case where you're not going to have it set equal to 0 because you're going to want the square term to be all by itself. When it is all by itself, what you can do is you can take the square root because that will reverse the fact that you're squaring x minus 3. And keep in mind when you take the square root, it's going to be plus and minus. That's usually what a lot of people forget. So it's going to be plus and minus the square root of 7. What happens is the root and the square cancel, so you'll get x minus 3 is equal to plus and minus the square root of 7. And then to get x by itself or to solve for x, just add 3. So here x is going to equal 3 plus or minus the square root of 7. Keep in mind this is two answers. One of them is going to be 3 plus the square root of 7, and then the other is going to be 3 minus the square root of 7, which will be two separate numbers. But you can leave them all together. So that's the square root principle. That one's pretty quick. Completing the square, again, we're going to do that later. The next thing is the quadratic formula, which you guys have seen is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. The idea is being able to find out what a, b, and c are. A is in front of x squared, b is in front of the x term, and c is your constant. What I would recommend doing is, if possible, reduce your original equation. For example, 8, 24, and 18, those are all divisible by 2. So just to make the numbers more manageable, I'm going to take everything and just divide it by 2 to reduce my original equation. So this is going to be 4x squared minus 12x, and 18 divided by 2 is 9, equals 0. So from there, here you get your new a, b, and c. A is going to equal 4, b is going to equal -12, and c is going to equal 9. I might just start singing because I can't do it without it. So there's a song that goes along with the quadratic equation, and it goes a little bit something like this. It's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And I don't know why that helps me, but I always remember it. So we're going to have x equals -b, so that's going to be positive 12, plus or minus the square root of b squared, which is 144, minus 4ac, 4 times 4 times 9, all over 2a, all over 2 times 4 is 8. What I would do is maybe see what is 4 times 4 times 9, and it is actually 144. So what happens is that you're going to get 12 plus or minus the square root of 144 minus 144 over 8, which is 12 plus or minus the square root of 0 over 8. So 12 over 8. Normally this will yield 2 answers, which is 3/2. This is actually a repeated 0, which means that when you graph it, it's going to look a little bit like this. It's going to touch down at the axis at 3/2 and then hop off of it. So it's repeating both on the left, so it's coming to that 0 from the left and the right of the graph, which my hand was in front of that, so it's coming to 0 from both sides. A non-repeated 0 means that it crosses through, so it'll look something like this. So repeat, non-repeat. All right, so that's going to be the last of the first video. Here's the nice last shot of this last problem, and we will pick it up again with factoring with higher degrees.